Welcome back to part 2 of RSLinx. When we left part 1, we said that we were going to be discussing helpful RSLinx utilities. The backup restore function, launch control panel. Sounds like the name of a song, doesn't it? Launch control panel. And RSLinx Assistant Central. Now that's changed a little bit. It used to be from the help tab in the menu that you could go right to online help with RSLinx. That's no longer available, but there is a lot of actual help built right into RSLinx. Okay, backup restore utility. This allows you to save your RSLinx driver configurations into a file and then restore them at a later date. So if you move from laptop to laptop or workstation to workstation, you can carry this configuration file on a jump drive, you restore it, and your drivers are all set up just the way they were on the other machine. So you go to the Start menu, Rockwell Software, open up the RSLinx folder, and select the Backup Restore utility. And of course comes up with a choice to either backup or restore. If you haven't backed up anything, well, you've got nothing to restore. So we select backup, and then we pick a location to save the configuration file. Now I didn't pick any particular logical place. Ordinarily I would have a folder called RSLinx configurations, and I would save it there. So pick a location that you want to save your configuration file to, and then give your configuration file some kind of a clever name. It could be based on an area of the plant, it could be based on an actual plant, but a name that will make sense to you when you want to recover the appropriate file. Then you click on Save, then you close the file. And then, sometime later, could be weeks, could be that same day, might be months or even years later, you want to restore that either because your hard drive crashed or the laptop got misplaced, or you find yourself at another workstation. You haul out your jump drive, or you go on the network to the server and find your configuration file. So at a later time, you go back to your Start menu, Rockwell Software, RSLinx folder, drop down and pick the classic Backup Restore utility. And now, because you have something backed up, you can restore it. So you select Restore. That opens up the same pop-up. Now you're going to have to find your way to the location that you stored it. Then you're going to select the file. I just called it Timmy2. That's the suffix, or the .rsx is the RSLinx configuration. And then open it, and you'll very quickly get an operation completed successfully. Click OK, and voila, it's just the way you saved it. And of course, as I explained, you can copy the backup file to another PC. You should try it. Even if you don't need it right away, give it a try. That way you'll have some experience. Okay, another utility is something called running RSLinx as a service. If you run it as a service, it starts up and runs whenever you start up your computer, and it's always running in the background. Even when you shut down RSLinx from your desktop, it's still running as a service. You may or may not want to do this. Running it as a service has caused some people problems with Windows 7 64-bit. Don't know the reason why. So you select RSLinx Launch Control Panel, and you get a very simple set of choices here. If it's stopped, you can start it. If it's started, you can stop it. So you select whatever feature you want. It says it's not running, so you can start it. Then you also have Run as a Service. You have to have administrative privileges in order to check or uncheck this box. And then close the routine. The other thing we mentioned was online technical assistance. And it used to be when you clicked on the Help tab, one of the choices was online help. Now what you have is RSLinx Classic Help. You can also click on What's This, and that turns your cursor into a pointer with a question mark on it, and then as you click on things, it gives you some help files. Then there's a quick start. So you need to look over the help files, and there's also a manual at this link. So you could pause the video at this point and kind of look it over. literature.rockwellautomation.com, IDC, that's probably industrial controls, groups, literature again, documents, GR. It's quite a lengthy link, but anyway, there it is. That'll take you to an RSLinx manual. Okay, those are the useful utilities. Now we have another point that we want to make about RSLinx. When you go online or download from RSLogix, you have to decide whether you are going to pin the tail on the donkey or you're going to look where you're going. Now, if you don't know, pinning the tail on the donkey, that's a kid's game they play usually at birthday parties, where they have a poster of a donkey with no tail. And then they have a tail with a thumbtack at the top of it. They blindfold the kids, spin them around, and then let them try to find the poster and pin the tail on the donkey. In other words, they're doing something, but they really aren't looking where they're going. They can't see where they're going. You'll see the sense of this here in a second. So, from the online toolbar, you see right below the online toolbar it says driver, AB_DF1-1. But you notice there's no file open, there's no project open. In RSLogix 500, this says microstarter light, same thing. It remembers the last driver it used. So, if you're going to use the online toolbar to download or go online, this is okay if you only have one PLC on your interface. However, you don't really know where this is going to go unless you know for sure where that driver went last time. So I usually tell people to avoid using the online toolbar to upload, download, or go online. Okay, so if you click on offline, the little drop down arrow there right by offline, these are your choices. You see there under offline it says go online, download, upload. You really don't know where that's going unless you've only got one controller connected to your laptop or your workstation. If you're on an Ethernet network, or if you don't know for sure what controller you're connected to, I wouldn't use this route. So you don't really know where you're going with the question mark there. Now, choosing the path is how I teach people to do it. You go to comms, click on system comms, and it pops up with an RSWho looking thing. It literally is RSWho, but it's tagged a little different. So you find the driver, you open up the driver, find the controller that you want, click on it, and then click download. Now notice the first pop-up there that has the 3 on it. If you look over there, see it says online upload download, but it's grayed out. Until you actually pick a processor, you can't online upload or download. Once you pick the processor or a processor, then those 3 buttons are no longer grayed out and they're enabled. And then you're going to go ahead and continue to download. However, it's going to ask you to save your program first. So to save your program, you pick a place to save your program, you give it a name, and then you say save. And now it wants to download the project to the controller. And so this is a no guts, no glory message. You should read this at least once. I typically don't read them anymore. I recognize it, and it's basically saying you're downloading this program to this processor. Now I just noticed that it says MicroLogix 1100 Series A to a Series B. So that 1100, I just looked at it the other day, it says Series A on it. So someone must have flashed it to Series B. without me knowing it. It was something I purchased. Okay, so you would say yes to this to continue the download process. Then it comes back and it says, but wait, the processor is in the remote run mode. Processor must be switched to the remote program mode. Continue. What that means is, do you want them to switch it to the remote program mode? Because you could lean over, if you're near it, use the key switch to switch it to program and then back to the middle position so it stays in remote program. So I just click yes, and now it's downloading. And we have a little progress bar here. It'll continue until it's done. However, in this case, I got another message, and it's a good thing that you're seeing this. There are normally 2 channels on every controller, on most controllers. 2 COM channels, channel 0 and channel 1. I'm downloading this through channel 0. My offline file that I'm downloading has a configuration for both of those COM ports, channel 0 and channel 1. I'm downloading through channel 0, so I know they match, otherwise I wouldn't be downloading. But channel 1 in this case is Ethernet. So basically that means the Ethernet IP that I have in my project offline doesn't match the Ethernet IP that's actually in the controller right now. So if I hit apply, it's going to overwrite the configuration for channel 1. If I hit don't apply, then it will go ahead and download, but it won't overwrite the configuration on the other channel. So we'll hit don't apply, and so the downloading is done, and it's in the remote program mode because we said, yeah, go ahead and change to remote program so we can download. So now it says change back to the run mode. Of course, I'm going to say yes, and voila, there we are. There's our little 2-timer program. This is a typical flasher, and I'm using the timer timing bit on an output. So I have 2 timers, timer 0 and timer 1. Now I call them timer 1 and 2, but you see it's T40, T41. And if you read the code, if T41, the second timer, is not done, then it enables timer 0, T40. When it's done bit starts T41. So T40 runs for half a second, 500 milliseconds, and then it's done. And then T41 runs for a second. When it's done, the run goes false, resets both timers, and they start over again. So the timer timing bit for timer 1, which is a 500 millisecond, 1/2 second preset, that timer timing bit will be true while the timer is timing for 1/2 of a second. So that output 0.0 will be on for 1/2 a second. So you can play around with the presets on these timers to get the exact kind of flash that you want. Okay, RSLinx Toys. There's a thing called a smart cable. The folks that have been around for a while, they've probably seen one of these. It's like a switched breakout box with LEDs and a ribbon cable, and on the end of the ribbon cable it has 2 25 sub D shell connectors, 1 male, 1 female. Then on the actual adapter, the converter, or the pinout box for the LEDs, it has another 25 pin D shell. And then you use combinations of 25 to 9 pin, male, female. This allows you to make any kind of RS-232 connection you could imagine. And then there's 3 switches on the little breakout box with the LEDs, and by putting those in the right positions, the LEDs will tell you when you have a good RS-232 connection. Okay, that's always a good thing to have around if you have a lot of RS-232 devices but don't necessarily have all the right cables. Then there's the 1747 CP3 and the NC13 2711. 2711, that's the prefix for panel views. 1747, that's SLC 500. And then you have 1784, which is the prefix for PCM-CIA adapters. KT, PKT, I think the PKT is a card that you can put in the slot of the motherboard of a tower, or the old CPU box style computer. PCMK, that slides in the PCMCIA port, and that comes in DH plus and DH45. Now there's another adapter that also is PCMCIA for DeviceNet, and there's one for ControlNet. These things are about $1,200-$1,300 a pop, and another couple $100 for the cable. They're not an inexpensive way to go. And this is the PCMCIA adapter for ControlNet, and that's the one for DeviceNet. Now the 1770 KFD, we call it the Kentucky Fried Dog. We'll spend a little bit more time with that in a minute. And then of course the 1747 PIC. Danger, danger, danger. This is a Windows 95-98 thing. Does not work real well with 2000, XP, NT, you name it. That's because the handshaking on this older electronics was expecting a fairly fast return. But with all the layers in the newer operating systems, it takes a little longer to get the handshake back, so it will fault. In other words, it'll drop communications. This thing is also the kiss of death with NT 2000 and XP, because if you go in and delete this driver with, wait a minute, in order to get this thing to work on NT 2000 XP or newer, you have to go into the driver setup and check a box that allows this driver to permanently grab a hold of that COM port and not let go of it for anything else. In other words, it owns that COM port as long as that driver is configured, and you can't use that COM port for anything else no matter what. So if you're going to delete the driver, you have to go in and uncheck that box, then go out of configuration, and then go delete the driver. If you delete the driver first, well then it's too late. There's nothing to go uncheck, and not only does that driver not work with that COM port anymore because you deleted the driver, the COM port doesn't work with anything else either. So you actually have to go into software, hardware configuration, device manager. You have to delete the COM port, reinstall it, reboot to get your port to work again. So I always tell people, if you got a 1747 PIC module, set it on the end of the bench at work and accidentally bump it off onto the floor and then accidentally bump something real heavy on top of it to smash it. Now that's not good advice. Your boss wouldn't like me saying that. Anyway, 1747 PIC, kiss of death with NT 2000 XP. Now it works fine with 95-98. Okay, this is a new toy, but relative to the history of PLCs, not in terms of you just graduated from school 4 years ago, new toy. This is an older toy, and it's a USB converter that will allow you to convert to RS45 or RS232. Now we're talking about USB to electrical RS45 and electrical 232. So the converter interfaces to RSLinx version 2.43 using a standard DF1 driver and is compatible with Windows 98 ME 2000 and XP. So this really is a PIC replacer. So you can get rid of the PIC module. And there's a little slide switch. So you electrically move the switch. So you electrically change it, switch it over from RS45 to RS232. And for the space cadets, heat seekers, and bit heads out there, here's a little more information. If you want to pause and make note of what you specifically need, help yourself. Okay, talking about cables. Let me catch up with my notes here, because I started rattling on and was not using my notes. This is material that I've known for a long time, so I tend to not use the notes. But don't be too quick to think that this is an Ethernet cable, by the way. It looks like an Ethernet cable because you're looking at RJ45s. This is actually for DH45, and these are older devices and a computer without an RS232 port. So this diagram that will pop up now is the actual wiring diagram. It's kind of blurry. I got this right out of the manual. That's the best resolution I could get. So again, you can pause here, but you can see this is straight through. Pin 2 to pin 2, pin 3 to pin 3, pin 5 to pin 5. So a 1747 C13 cable is straight through 2, 3, and 5. Easy to make up. And you see they're calling it catalog number 2711 NC13, NC14, and 2706 NC13. And they show it going to SLIC, Compact Logics, and Micrologics to a panel view terminal. Okay, if you're going to connect DH45 devices to that PIC replacer, you can do it. In the previous, we had the C13 cable, which looks like an Ethernet cable. It's not, but it has two RJ45s on it. This one is actually a RS-232 cable, the 1747 or 1756 CP3. This is the standard serial cable that you use to go from the RS-232 port on your computer to the RS-232 port on SLIC 500, Compact Logics, Control Logics, Flex Logics, or an AIC Plus module. The other end of it can plug right into your personal computer, or if your personal computer does not have an RS-232, or that port is busy with something else, you can use the USB adapter, the 1747 UIC, which we just went over. Okay, and this is the pinout for the CP3 cable. And as you can see, it's a crossover cable. So you can see pin 2 and 3, 3 and 2 are crossed over. When you're going from an RS-232, a DF1 device to a DF1 device, we'll say, then you have to swap receive and transmit. You don't want to transmit to their transmit. You want to transmit to their receive. And that's what sets these apart. Plus you see pins 4 and 6 are also swapped. Okay, so it's not just simple, and you can see 7 and 8 are swapped. So this is quite a crossover cable. Connecting DH485 devices to the 232 port. This would be using the PMO2 cable. And this is the cable with the round DIN connector on the end of it. This is not a 9-pin to 9-pin. This is a 9-pin sub D shell to the round DIN connector. Very common cable. You can find these on eBay, very inexpensive, for 10, 12 bucks. And this is the cable that you use to go to Micrologics from RS-232 or a USB adapter. And this is the pinout. I probably would not take it on myself to make one of these unless there was absolutely no other way to do it, because you can buy one for about a half hour's worth of your time. Okay, NC13, we actually already showed this in an earlier slide, to go to panel view 300 or higher from the UIC. This is the pinout, and you can see that pin for pin is straight through. Now also on that UIC, right there, 1747 UIC, you have 3 LEDs. And you want to pay attention to these 3 LEDs. As a matter of fact, in this chart right here, this is a more in-depth troubleshooting chart, and this is available in the manual for the UIC. The UIC comes with a little folded up sheet. Don't throw that away. Yep, that was all from publication 1747 IN 063B-English-P. That little wadded up installation instructions that came with the device, and you probably wadded it up and threw it away. So hold on to it in your toolbox. Don't throw it away. More toys. This is the newer USB adapter, but it's strictly RS-232. There's no RS-485. This was version 1, and version 1 did not support auto configuration. If you see the red arrow, it says note. Does not support RSLinx auto configure. Well, that's not a good thing, because auto configure is a nice thing to have. You can also download this from the website if you lose yours. This is version 2. This is a newer version of the same device. This is what I have. This supports auto configuration. A note to make here, make sure you uninstall version 1.0 drivers before you load the new drivers. These are not plug-and-play devices on some operating systems, so be careful what you're doing, read the instructions. Okay, with any USB device like this, you have to know what the COM port assignment is. So if you go to My Computer, right-click, Properties, this is one way. You could go to Manage as well. Hardware, you can see this is an older screen capture. Device Manager, go to your ports, COM and LPT, and right there it says that this device, this USB device, is plugged into COM6. You have to know that. So make a note, COM6. It'll be different on every computer. Close this box. Okay, now you go to RSLinx. Click on the double-headed snake there. One byte from one of those, and it's a hospital job for sure. That's Configure Drivers button. Select RS-232 DF1 devices. Say Add New. I always keep the default name, AB_DF1-1. You can name it anything you want, up to 15 characters. I leave it with the default name, that way I know what kind of driver it is. If I put Building 4, who knows what Building 4 is? Click OK. Now, you have to go select your COM port before you hit Auto Configure. So you would drop down the list next to COM port where it says COM1, pick COM6 or COM5, whatever it was. Then hit Auto Configure, and it'll say Auto Configuration Successful. At that point, you're home free. Click OK, and you have just configured the most common driver in the annals of RSLinx. Okay, close the configured drivers, then go to your RSWho button with 3 little computers on the network. Click on that, and it brings up RSWho. Now you can open as many RSWhos as you want. So you would have RSWho1, RSWho2, RSWho3, and so on. We only need one. So we've only got the one driver we just configured, so we expand that, and it sees the workstation, you know, the computer that you're working with, and it sees a Micrologix 1500. There you have it. That's the RS-232 driver. And as usual, I'm way ahead of my notes. Sorry for the noise. And now we come to the Kentucky Fried Dog 1770 KFD. This is a DeviceNet adapter. Looks kind of like the PIC module. I don't know if people use these anymore. They still work. There's nothing wrong with them. A lot of people use pass-through, or there's another adapter you can use. So we go to RSLinx Classic. We go to our double-headed snake, configure drivers. We drop down our available driver types, and we pick DeviceNet drivers. See, that covers them all, PCD, PCIDS, and the KFD, and the SDNPT. So that one driver covers all of those devices. Remember, drivers make the connection between a device and the object that you want to communicate with. So we pick that driver. Then we say Add New. Now, one more time, it's going to ask us what device we have. We have a KFD, because remember, this driver works with all 4 of these. So we pick the KFD, we hit Select, and it comes up with a fill in the blanks box. Not only do you have to pick the COM port, but you have to pick the data rate, the node address that you want to assign to this device, and the data rate. Now this is important. We're not going to go into DeviceNet right now, but this is information you kind of have to dig up yourself. Click OK. when you see this, the green check mark, that means you're golden. And we're going to close. Now, we opened up RSWho, we expanded the driver, and there you can see a 1756 DNB. That's on DeviceNet, and you can see well, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 other devices. Well, we won't count Workstation, the bottom one. But you have a DeviceNet panel view. Looks like what they called butter stick I/O because it's about the size of a stick of butter. Then it looks like some on-machine I/O, and then there's a 802T with mini connector. You can plug many little things in that. There's a photo eye. I don't remember what a DSA is. It's been a long time since I took this screenshot. Anyway, you can browse right on DeviceNet because you are now actually on DeviceNet through the KFD. So you can go out there and you have access to right-click on any of these, drill down and check out the details on them. Okay, so we selected the driver. Now, we're leaving DeviceNet. Remember, this is RSLinx, not DeviceNet. Ethernet is also something that you do in RSLinx. Now, I don't know that we'll do Ethernet in this presentation, but a couple little tips here for those of you that don't do a lot of Ethernet. Finding your IP addresses. So if you go to the command prompt down at the bottom by the start menu button and open that up and type in ipconfig and hit enter, it's going to show you the IP configuration of all of your adapters. Now this particular laptop has a wireless LAN adapter, and you can see the MAC ID. Well, no, it's the IP6. Never mind on that. Anyway, the IP address is 192.168.1.133 with a subnet of 255.255.255, or you can call it a 24-bit subnet. And then right below that, Ethernet adapter local connection 192.168.1.100. And then there's some more things down below there. So quite a bit of information doing IP config. Now, if you want to check to see if an Ethernet address is out there, then you want to do a ping. And I didn't have this in the last slide. It should have been in there. But you go down to right above your start button, and there's a open field there. You type in CMD. Don't type in command. Type CMD. And when you hit enter, you're going to get C:\\whatever. Now mine says PLC Professor because that's the computer. So you want to type in ping space and then the IP address that you're looking for. When you hit enter, this is what will come back. It'll come back pinging 192.168.199 with 32 bytes of data. Reply, 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 reply. It gets 4 replies. Packet sent 4, received 4, lost 0. That's a good thing. That means that IP, that there's a device out there, a NIC, Network Interface Controller, that is assigned that IP address. If there isn't a device out there like that, you're going to get this, unreachable. So those are 2 little Ethernet tips. IP config to find out what your IP address is, and pinging to find out who's out there. Okay, another thing we want to talk about is, and I think we'll pause here and we'll come back to the 1 COM port blues in the next section. I think we've extended past our 12 to 20 minutes. So, okay, this will be the end of part 2 of RSLinx. And when we come back, we'll continue with the 1 COM port blues. That's where you have a controller that's only got 1 COM port, but you want to plug your laptop into it and an MMI HMI at the same time. So go to part 3.